Let's go ahead and try to graph equations by finding a table of points of x, y ordered pairs and then going ahead and graphing them. And we're going to find those points by solving the equation for an input value for x and then find the output value for y. And let's just go ahead and start with, let's say, this equation here. We've got to take a look here. It turns out that there is a negative here. Let me maybe zoom in here a little bit. Make sure you can see this equation. I think I'm going to have to bring this down. There you go. So you can see that the equation has negative x plus 3. So if we put, and it says in this particular problem, find at least 5 solutions. The very minimum number of points you want to find in trying to graph by plotting points is going to be 3. Because if you make a mistake in just plotting 2 points and draw a line, any 2 points will give you a line. It may not be the right 2 points. There may have been a mistake in calculating them. So the third point acts as a checkpoint. But in this case, we're going to go ahead and find 5 points, so that should be plenty. And this is a linear equation where both x and y are to the first power. And when you graph linear equations, their solutions, which we're going to be finding 5 of, will always be collinear. So we'll know we made a mistake if any of the 5 points don't line up in a straight line. So let's just go ahead and, this standard numbers, nice numbers to put in here would be maybe a spread of -2, -1, 0, 1, and 2, but theoretically you could put any values in here. And it turns out that when I put -2 in here, because I have this minus in front of x, I'm really going to get this. Negative of -2 plus 3 is going to be actually +2 plus 3, or 5. That's our corresponding y coordinate. So far we have the point -2, 5. We're going to keep going here, and we'll put a -1 in. And negative of -1 plus 3 is going to be a +1 plus 3. And that should be 4. So we have the point -1, +4. Then we put a 0 in, and the negative of 0 is still 0. Plus 3 is going to be 3. And we have the point 0, 3. And that we're also going to be talking about in the next section will be the, it'll turn out to be the y-intercept, because this being 0 for x will mean that I'm going to cross the y-axis with that point, or at that point. And then I'm going to go ahead and put a 1 in, and +1 in here is actually going to give me a -1 result. And -1 plus 3 is 2, and I have the point 1, 2. And then I put a +2 in there, which will produce a -2 plus 3. And that is going to give me a point of, that'll give me an answer of 1 for y, but that'll be 2, 1 for the point. So all I did out here, and maybe I should just go ahead and do this, I'll put a colon here. These are just the ordered pair results from putting -2 in and getting 5 out. The ordered pair -2, 5 is a solution to the equation. In other words, when I put -2 in, the result is 5, and I have an ordered pair that's called the solution to the equation. Now, these equations have an infinite number of solutions, which the line that we're about to draw really represents all the solutions to the equation. We're just using 5 to give us a guide to get the rest of the points that the line represents. So I'm going to go ahead and start plotting here. And we learned in the last section how to plot ordered pairs. -2, 5 would be over 2 in the negative direction and up 5, and we'd be right here. -1, 4 would be over 1 in the negative direction and up 4. 0, 3 is right here on the y-axis. I move nowhere in the 0 direction and up 3. 1, 2 would be over 1 and up 2. And 2, 1 would be over 2 and up 1. And things are lining up, looks like, pretty well. And so here we have it. We have a line that represents not just those 5 points, but all the other solutions, any other value we would have put in and got a corresponding y value out, would land on this straight line. In other words, we can make a prediction, for example, here, if I went over 6, well, if I put 6 into the equation without actually doing it, it looks like I'd go over 6 and down 3, I'd get an answer of -3. And that's because this line represents all the solutions to this particular equation. Okay, so I think I just want to introduce one other problem. It's this right here. What if you have a fraction? And I don't even think I'm going to go as far as graphing this just for the sake of time. But if you have a fraction here in front of x like this, just pick points. Now over here, I use that -2, -1, 0, 1, 2 that is often used in the book, in our textbook, in the homework to go ahead and find 5 points. But here I think I want to work a little differently. I want values in here that, just so my calculations aren't so difficult, I think I'll put values in here that divide nicely by 2 so I don't end up with fractional answers. And not that fractional answers aren't valid answers, it's just that I don't want to do that extra work if I could avoid it. So I think I'll put things like maybe -4, -2, 0, 2, and +4. And when I do that, here's the calculation, just a little review of fraction work. I'd have -3/2 times our input of -4, which I'm going to make a fraction over 1, plus 2. And what happens here is the product of the two negatives gives me a positive, but I'm going to get 2 cancels with 4 to give me 2, and I will get +6 plus 2 here. And my answer is 8. And I'm just going to go ahead and do one more just to show you how this works. And if I put a -2 in there, it would be -3/2 times -2 over 1 plus 2. And that would be, again, a positive answer, but 2 and 2 cancel. And I'll get -3 times really -1, or +3 plus 2 is 5. And the reason why I'm getting a 3 is because the 2's canceled not to 0, but to 1, really, to -1. And -3 times -1 gave me 3, plus the 2 gives me 5. And I just keep going like this, but like I said, I just want to introduce how to do that. Once I get the ordered pairs, -4, 8, -2, 5, and whatever ordered pairs I get here, I'd be plotting just like I did up here.